Welcome to the third installment of this lathe restoration. So if you've seen the last video, you would have seen I made up these pulleys here, and then I ran into a bit of an issue where the belts that I'd purchased had an included angle of 30 degrees, and that was not going to allow for the full range of speed that I want to come through the spindle here. So these pulleys are actually no good for this project now, but I can use them in another project. So I've gone out and I've bought another belt. So this belt here has 22 degrees included angle on it, and that's going to work a lot better for us. Now I mentioned in the last video that I was going to put the motor off the back here, so it sort of goes out like that. That was only because I didn't think I was able to get a long belt. But I think this belt is long enough to have the motor where it is there now. And I prefer it to be where it is there because that works better for weight distribution, down the center of the lathe there instead of hanging off the back here. So if this belt is long enough, then that's where it will be. And if you had seen the last video, you would have seen that I was going to have the CVT in the middle here. But now I've changed the plan and I'm going to be putting a pulley here and a pulley down the bottom, and it's just going to be those two pulleys. And both of those two pulleys are CVT pulleys and they sort of work together. You'll probably understand a little bit more as we go through the build and get it all done. The first thing I'm going to do here is work on the pulley for the motor, and instead of making them out of aluminium, I'm going to actually make them out of steel. Because we're now using an included angle of 22 degrees, I have steel which is thick enough to make these pulley sheaves. So let's get started. This is 25mm round bar, and this goes on the motor shaft. So I'm drilling and boring it out to around about 16mm. And that fits on there perfectly. This is a circle jig for a plasma cutter. I'm going to be cutting out the sheaves or sheaves. I center punch the middle of the sheave and then drill a 6mm hole in there. I got this idea off the Make It Custom YouTube site. So now we go to the plasma cutting drawer. Of course we need the ground clamp attached. Pretty exciting. This is the first time I've ever cut a circle with the plasma cutter. And nothing's happening. I had to troubleshoot this for about a day, reviewed a lot of websites, and I couldn't fix the plasma cutter, so I think it is actually broken. So now we go back to old style, and I'll have to cut these out with the grinder. This is 12mm thick steel plate. It's actually a dental chair. I won't bore you with all the cutting out. So basically I end up with these 4 pieces, and they've been center drilled as well, so I can dial them in the lathe. Now 2 of these sheaves need driving bosses on them. This is 40mm rusty round bar. We go to the lathe and clean up the end. Put a center drill in there and clean up the surface. This is a 34mm step. This will go through the sheave and this part will be welded on to the sheave. So I make 2 of these parts. Now I'm dialing in the first sheave. I need to drill and bore this sheave out so that it can fit that driving boss. I give it a bit of a test in there, and that looks like it will press in nicely. Over to the vise, and we press that into the sheave. Once that's done, we weld it in there so that it's not going to move or come out. And of course we weld the other side as well. Now we put that in the lathe, and that driving boss had a centre on it, so I can centre up the disc, and we turn down the outside. And then we start turning the 11-degree angle. I had to take very light cuts, about 4 to 6 thou on each cut, so it took a little while to get all the way through. The last step is to drill and bore out that centre to 25mm. I test that on the motor shaft, and that fits on there nicely. Now I was quite curious because the weight was substantially lighter once machined. So I weighed these up, that's over 2 kilos. And the machined one is less than 1 kilo. And this is where the other kilo of steel went. I've made both of those drive sheaves, and now we're working on the third one. So again, this is another boss to go into the centre. And the centre of the sheave is drilled and bored to take the boss. Again, we weld that on. This one is only welded on this side. This is for the motor, and it will have a spring going around this piece. So that goes into the lathe, and we do the same process. Clean up the outside, cut the 11-degree angle, and bore out the centre. And that fits on the shaft nicely. So one more to go. Now I'm going to work on the spring and other bits and pieces that this sheave needs a little bit later on. Now we work on the last one. Again, it has a boss, and this is made a little bit differently. So it has a part that goes into the sheave, and it is machined down here for a bearing. That gets cut off. It gets pressed in, and you can see there's a little shoulder there. That's where the bearing will go up to. Now I need to make the part that the outside of the bearing will go onto. I found this piece of aluminium, and I bore it out to the size that we need for the bearing. And then I drill a couple of holes in the side, and this is for the fork that will be attached to move the sheave in and out by the control lever on the front. The bearing is first pressed onto the sheave, and that goes on nicely. A little bit further there. And then the aluminium piece is pressed onto the outside of the bearing. That aluminium piece turns independent to the sheave. I've finished machining the sheaves, and this is sort of how they work on the machine. So there's two that are made up like this, and these will be fixed. So I will drill a hole and put a set screw or something in here so that these can be fixed to the shaft that they're on. So one of those goes down to the motor, and the other one goes on the spindle, but I'll put that on last because it's the last one to go on. The next sheave is the moving sheave for the motor. So that's a little bit different here. It's able to spin on the shaft, and there will be a spring that goes over this piece. I didn't have a spring big enough, so I'm going to have to make a spring. So I'm going to do that a little bit later on once I get the motor all sorted out and mounted, because it depends whereabouts on the shaft this needs to go, and I need to cut the shaft and put a bit of all thread in there and a lock nut and other bits and pieces, so there's a little bit of planning to go on for that. So that will go on there like that. And this is the movable sheave for the spindle. This is the one you just saw me made up. So it has a bearing in here, and this is able to spin because there will be a fork bolted onto here, and this fork will move, which will slide this sheave, you know, in and out on the shaft. So that goes up there on the spindle. And then the fixed sheave for the spindle, so this is exactly like the first one I showed you, we'll have a set screw put in here, and that will be fixed onto the spindle there. So the outside here and the inside here will be fixed, they will be aligned, and then the top one here closest to the headstock will move in and out, and this one down here on the outside will move in and out, and that's under spring tension. Of course, the belt goes in between here, so when the spindle sheave is moved via the front lever mechanism, it will push the belt out to the outside like this, and that will give you a big or larger pulley here, and that will allow the lathe spindle to run at a slower speed. And then when we move the lever to push the sheave back, the belt will ride down lower in here, and it will be a lot higher down below on the motor sheaves, and that will run the spindle at a much faster speed. My next steps here are to make up brackets for the motor, and the motor will be mounted to a plate that is on a hinge, and then there'll be an adjustment in the front so that the belt tension can be adjusted. The first thing I'm doing here is drilling and tapping the holes in these fixed sheaves so they can be mounted on those shafts. Now I'm getting some measurements for the mounting of the motor. We're starting with a piece of steel for the mounting plate. This is drilled and tapped out to M10. This will be welded to the stand for the lathe. This next piece is the motor plate. I mark out where to drill the holes to mount the motor onto this plate. Those are firstly drilled out. And then tapped to M8. I'm test fitting the motor onto that plate. I have it all propped up in there, and I'm taking some measurements for the height adjustment plate. I cut off another piece of steel for that height plate. We are at the mill, and I drill a series of 3 pairs of holes in that height plate. Once the plates are complete, I'll work on the hinge. This is 16mm round bar. I drill a 8mm hole down the middle of that with a very, very long drill bit. I need to cut this round bar into 5 pieces for a 5-piece hinge. So they're all marked out at 20mm apart. I cut off all those pieces in the lathe. Once they're all cleaned up, I assemble them onto the bolt, and that is our hinge assembly. The motor plate and the height plate are propped up on the bench, and the hinge is put in place and welded. I then turn it over and weld the other side. And the moment of truth, yes, that works perfect. I use this huge double-ended C-clamp that I made to hold the mounting plate on the lathe so that I can weld it in place. Then I remove the clamp and remove the height plate and the motor so that I can finish weld the mounting plate. I'll put everything back together and give it a test, and it works perfectly. Now I need to work on the other side of the motor. So I need to make up some sort of adjustment here so this can be adjusted. So what I was thinking of is having some all thread, and the all thread is fixed somewhere onto the side of the stand here, and then there's a slot cut in here, and then I can put some jam nuts on there. Now the issue that I have, and I don't know if you can see it on camera, but this is instead of being level out here, this is pointing on an angle down, and then when it's lifted up it kind of points on an angle up. So the thread and jam nuts would not be sitting flat on each side of this metal plate when I tighten them up, depending on what position that's in. So I thought the way around that would be to use maybe some round bar and put the all thread through the round bar, and then put a jam nut on the top here and use a bit of round bar at the bottom, and also try that again, and also have a round piece at the bottom, but I'm going to put a thread in this piece, and that would just clamp up tight on the bottom there, and you'd have another round piece on the top which has a clearance hole, and then a jam nut on top of that, and I'll just lock the all thread onto a little bracket that comes out the top here. When doing home machining, you should never say no to free steel when people offer. I've run out of 20mm mild steel, and I found this piece of stainless steel that I was given. Everything was working fine, and I was just stepping my way up the sizes, and then this happened. That is the sound and smell of the stainless steel work hardening and burning up a drill bit. So that hole was no good, so I tried the second hole, and everything was going fine here again, just stepping up 1mm at a time, and then it did not like this one. I had another look around, and I actually found a piece of mild steel that would work. I drilled that out and tapped an M12 thread in there, and that worked fine. I cut those pieces off, and once they're all tidied up, this is how they fit onto the all thread. Now I need to cut a 12mm slot in the motor plate for the all thread to fit through. I test that out on the lathe, and I see we have a problem. Well, you can probably tell that I didn't do too well at skill and geometry. This doesn't work the way I thought it would work. Once this nut is tightened down, the rod is pretty stuck in one place. So as you can see, it's pointing away from the lathe that way, and once you come up here it starts pointing to the lathe. So I don't think this is going to work too well, so I'm going to have to come up with a different idea. The idea here is to have the 20mm threaded bar that I made fit inside this piece so that it is able to pivot. I need to cut a slot out both sides for the all thread to fit through. This is the plate that the all thread goes through at the top, and it is welded to the lathe stand. I give it a bit of a tidy up here on the edges and shape them round a bit. That just makes it look a lot better and saves me catching my clothing on any sharp edges. I then prop everything up and clamp it together and then weld that plate on the top there. And I do something similar here with the motor plate. I just cut the corners off and grind it round to make it look better. Now I need to weld that outer sleeve onto that motor plate. This is how the adjustment mechanism works. The bolt goes through, screws into the little pivot, and then the motor can lift up and down, and you just tighten up that lock nut. There's another view of it, a different angle. Now I need to make the spring that goes over this motor pulley, and it will go over that center boss and rest on the pulley face itself. This is 12mm square stock, so I need to make a guide for the wire, and I drill a hole down the center of that. Now I need to add some tension, so I'm drilling and tapping for a grub screw that goes on the side that I can tighten up on the wire when forming the spring in the lathe. This is the arbor for making the spring. In hindsight, I did not take this down small enough. I was trying to find information on arbor sizes, and at this point I couldn't find any. To hold the wire securely, we need to drill and tap. And this is a M8 thread. Now I do a test with 2mm piano wire. We manually wind a few rounds there. Then the half nuts engaged. Then the half nuts disengaged, and a few more rounds are wound. That did not work as expected. After finding some information on the mandrel size and doing a couple more test runs, I was ready to do the proper spring. That's the same process, a couple of manual coils, locking up the tension, and then half nuts are engaged, then a few more manual coils. And I'm just a bit cautious here, I'm not sure where this is going to spring, so I use the spanner on the chuck. And in the end, that turns out not a bad spring actually. Once the spring is done, I need to work on putting a thread in the motor shaft. There will be a nut and a cap that will hold the spring on to that shaft. And now we assemble everything up. The spring goes on, I made up that cap off camera, and there's a nut that goes on there. That all gets held together and that works nicely. Now the top end is our movable sheave, the belt goes on, and this is our fixed sheave. And I had to play around with the alignment and all that sort of stuff. This bit I did off camera as well. This is just a makeshift lever so I can adjust the sheave here. You'll see a bit later on that it is really rattly. Now I do a bit of belt tensioning. And we got it running. That's a slow speed when this top pulley is together, and that forces this bottom pulley apart. and then when released the bottom pulley comes close together and the top pulley goes apart. Now that might sound a lot worse than what it is. I take a few measurements here. And it's just a little bit hard to control and keep the RPM consistent there. Well, there you go. So you just saw this crazy contraption working, and it does function as a CVT. You would have seen there when I had this pulley closed up, it was nice and quiet, it wasn't too loud. Once I open this right out, it sounds like the Hogwarts Express going past right outside your window there. But I think a lot of that noise is there's no load really on this pulley when I've released this handle here. The other thing, the handle's just flopping around there. It's just something I jimmied up, just to do the demonstration. So there's a bit of noise in there. I've put a couple of washers on here. These bolts or holes were drilled out so when the bolt is tight, it's loose so that it can pivot. So I don't know why I put these washers on here, but that was a bad idea. All it does is make a whole lot of noise. So I think I can get it a lot quieter than what it is. You saw me make the spring down here. Wow, man, that was crazy. Watched a few videos. This old Tony's got a great video on springs. Man, he makes it look so easy. It seems to work okay at the moment. I was trying to find a spring from a scooter because they have similar types of drives, and this spring is quite big in there, so I may have a look at that. I don't know what tension these are supposed to be. It seems to run okay, although it does need some kind of stop here because you would have seen at the fastest speed, over 3000 RPM, the belt's still not riding on the top. So if I was able to pull this tighter and get this closer together, then this pulley would open right out and the belt would actually go and spin on the axles. It needs some kind of stop in here to stop that happening. You would have seen the RPMs here. It goes from around 700 to 3100, which I think is going to be a good range for a wood lathe, so I'm quite happy with that. It's taken me quite a while to do this, but I've got there in the end, and there is a lot more to do. Anyway, in the next video, I'll be building the lever. It won't be over here, it'll probably be in the front here. Maybe a similar type of thing, or some sort of dial. I'm not quite sure yet. So that'll come out the front here, and this will be all covered in, so that your little fingers aren't going to get chopped off. So that'll be all in the next video. Of course, I'll need to have some sort of on-off switch and maybe a emergency stop button at the front here somewhere. At the moment, I have no switch. I'm just plugging it into an extension cord and got to grab this thing before it falls down and hits here. And yeah, it's a little bit sort of Mickey Mouse at the moment. But as I said, there's a lot more to do. Following that video, I'll need to probably work on the spindle. You're probably wondering what all this get up is here at the front. The spindle sort of stops about here, and I had to make up another little bit that was turned down that fitted inside the spindle, and it had a thread that came through, and I put a nylock nut on there just to extend the spindle out so I could mount this pulley on there. So it's not going to be able to be used as a lathe with it like that. So I will need to work on the spindle and build a new one. And I think I mentioned earlier that this is stripped out at the front here, so it needs a new one to be built anyway. So I think that wraps it up for this video. If you did get something useful out of this video, then please click on the like button and click on the subscribe button and notification if you want to be notified when I release new videos. Thanks for watching.